Hello again everyone, welcome back to PTET Chemistry channel. My name is Dr. Ont. In this tutorial video, I'll go through these combined science. This is combined science chemistry, basically the three sciences combined into one subject, and as such the contents are a bit more diluted compared to the triple sciences or the pure science curriculum. Nonetheless, the students within this curriculum also did this thing called qualitative analysis. This is basically observation kind of test for ions, test for gases, and the accompanying results and observations. So there is a new curriculum. So this is the paper 3 alternative to practical, which is related to the actual practical for the combined science curriculum. And that has been around for the IGCSE combined science or the IGCSE coordinated sciences for some time now. In the theory paper, this particular table of results are not given. Of course, in the theory paper, when they ask you, it's typically more straightforward question. Typically, it's the test for gas or the flame test, whereas the test for cations and anions, which involve a little bit more details, usually come out in the practical paper. However, nothing is guaranteed. Now, there will be accompanying practical videos, practical demonstrations associated with this topic, and they will come as two parts. The first part will be the test for the cations. So tests for cations are basically positive ions. So I would encourage viewers, if you are viewing these, you should really watch the other practical videos as well, so that you will take notes of the observations for each of these cations with the respective aqueous sodium hydroxide as well as aqueous ammonia. You don't use them together. They are separate tests, and there are some instances where you would need to differentiate or to distinguish which one is which one by using one or the other reagents, where they will give you different observations, but there will also be cases where they will give you the same observations. So have a look through the other practical video. So it should be the first part. Whereas there will be a second part on the test for anions. Even though you see this is 19.4.1, this is in the anion topic where you have carbonate, and we already learned that all acid react with metal carbonate. That was in the acid, bases, and salt topic, as well as year 9 general equation. They will give you metal salt. They also give you carbon dioxide gas as well as water. So that is the general equations, general reactions between acid and also metal carbonate. And it is this carbon dioxide that we need to test for. And we test for gas from the previous topics already. We use lime water, where we bubble the gas into lime water. And this is what you would see in the video part 2. I bubble the carbon dioxide that I produce into lime water, which is a clear solution, and it will go milky. Whereas we also have this other reaction to produce hydrogen in the lab, where we have metal plus acid from the metal topic, as well as from the acid, bases, and salt topic. The POSO-CARMAZYL reactivity series, metals above hydrogen. So POSO-CARMA, and then the ZYL, Zn, iron, Pb, and then we have hydrogen, copper, silver, gold just below hydrogen. These are unreactive metals, so they are from the metals topic just before this topic was covered. So these are unreactive metals. They don't react with dilute acid, but the metals above, they all react with dilute acid. We are not supposed to react acid with these two very reactive metals. They are extremely explosive and violent. They'll be very dangerous to do in the laboratory because they are so reactive. Metal plus acid will give you metal salt as well as hydrogen gas. When I demonstrated in the practical video part 2 as part of the test for gases and anions, this hydrogen gas, we use a lighted splint. Lighted splint is the one with the flame still bright. So the flame will actually extinguish with a pop sound, very, very distinguished test for hydrogen. With oxygen gas, we produce oxygen gas in the lab through the decomposition of hydrogen peroxide. Not that you need to know what it is, but you should be able to balance the equations. H2O2 giving you H2O, as well as O2 as a diatomic oxygen molecule, and water as these dot and cross of these molecules are from the year 9 covalent bonding topic. And then you also learn in year 9 that you need to balance equations. So here our equations show 2 hydrogen atoms, 2 oxygen atoms. 2 hydrogen is okay, 1 oxygen plus 2 oxygen is 3 oxygen, so that is not okay. And I put a 2 in front so that I now have 2 water molecules. So 2 times 2 is 4 hydrogen atoms, 2 times 1 is 2 oxygen atoms, 2 oxygen atom plus 2 oxygen atom, 4 oxygen atoms. I put 2 in front there so that I get 4 hydrogen atoms. 2 times 2, I get 4 oxygen atoms. This equation is now balanced. Oxygen gas will relight glowing splint. As I mentioned, you will see this in the practical video number 2. So one test which I didn't show was basically the test for chlorine gas, but then chlorine gas has a bleaching property. Bleaches, basically it turns the colored litmus paper, whether you use red or blue, it will bleaches the litmus paper, it will turn the paper into white. So the idea is that it turns it into white color because chlorine bleaches litmus paper. Ammonia gas was tested. We produced ammonia gas when we added ammonium plus sodium hydroxide will give you ammonia gas. I'm just going to go straight to the table of tests. So this is the test for ammonium ions. It says you produce ammonia on warming, but if you produce any gas, if there is a gas, you have got to do something, okay? You have got to give what is the test. The test for ammonia gas is basically it turns damp. Damp meaning a little bit moist or wet. You just need to wet it with some water. Tap water is fine, but it has to be the red litmus paper, as ammonia is alkaline or is a base. It will dissociate in water, it dissolve in water to give you the hydroxide ions. This was stated in the acid, base and salt topic, where the pH is greater than 7 and we use moist or damp red litmus paper, it will turn to blue. So what is our test? We use damp red litmus paper. What is our result? Our damp red litmus paper turns blue. What is our identity? The gas is ammonia. The gas is ammonia. It comes from sodium hydroxide that you added to NH4+. This is called ammonium. These are cations. Ammonia is a molecule, as you learn from dot and cross in year 9. Nitrogen share 3 out of 5 outer shell electrons. I still have 2 electrons in the outer shell because nitrogen is in group 5. It has 5 outer shell electrons. On the other hand, we have carbon dioxide, where carbon will want to share 4 electrons in the outer shell, but this time with 2 oxygens. So each oxygen uses 2 out of 6 outer shell electrons because oxygen is 2,6 electronic configuration, such that I'm left with 4 more electrons on the oxygen there. What else do I have? I have chlorine diatomic molecule. So we know that chlorine is group 7 halogen molecule. Okay, so group 7 has got 7 electrons in the outer shell. From the periodic table, the first, the second, and the third shell, we got 7 electrons in the outer shell. They just share 1 electron from each chlorine atoms to give these covalent bonds. These are all simple covalent structure. Simple covalent structure has low boiling point and they do not conduct electricity. Hydrogen and oxygen are also diatomic molecules. Oxygen forms 2 covalent bonds with itself because with 6 electrons in the outer shell, as I mentioned just now, as it is a group 6 element, it really wants to just share 2 electrons to complete its outer shell, but it can also gain 2 electrons if its partner is a metal cation, such as in the metal oxide. These are the results of the test for gases, and they associate together with whatever reaction they produce a gas there. So this table is given in practical paper 3 or alternative to practical paper 3, or depending on if you're doing the IGCSE, it might be given in the other alternative to practical or the practical component. Now the test for carbonate. We know that every single carbonate reacts with acid. As I did mention just now, if you have metal carbonate, because carbonate is an anion, the metal is the cation. So cation and anion give you ionic compound between positive ions and also negative ions. And you should know how to combine formulas based in year 9. Okay, so this reacts with acid. Acid will give you salt. If you use hydrochloric acid, you will get a chloride salt. If you use sulfuric acid, you get a sulfate salt. If you use nitric acid, you will get a nitrate salt. So this one give you carbon dioxide and they give you water. But same thing here, you see bubbles. That's the first thing you see. Effervescence basically means rapid bubbling. So that means a lot of gases. We cannot simply say carbon dioxide is produced. We have to, include a couple of things. You have to have the test. What is the test for carbon dioxide? You bubble the gas into lime water. You bubble the gas into lime water. You bubble the gas into lime water. You should know the setup as I've shown in the practical video number 2. So do look through that video and find out how we bubble the gas into lime water, the setup. And the lime water goes from a clear solution into a milky or a cloudy or a white precipitate which you can no longer see through. So what is the test? What is the result? Bear in mind that the test is not lime water. Lime water is what you use. The test is what you did with the gas. You bubble the gas into lime water. The lime water turns milky. And then carbon dioxide is basically the identity of the gas. Just like with the ammonia earlier, we gotta have a test, a result, and identity. We produce a gas. What is the test? What is the result? What's the identity? Now, brief recap through group 7 chemistry. These are what you call the halide. The halide is an ion. It's basically IDE instead of INE. Chloride, bromide, and iodide. The test is basically acidify because every single acid has H+. You add dilute nitric acid first and then you add aqueous silver nitrate. Have a look at this term called aqueous. Aqueous is very important because you're adding solution and solution and solution and you get a precipitate. So in theory paper, you are not allowed to use the term PPT. So PPT is basically precipitate. This is a term that can be quite difficult and scary to spell. So precipitate, precipitate, precipitate. The reaction to produce the precipitate here by adding nitric acid and then aqueous silver nitrate is basically called precipitation reaction. Silver chloride is the white precipitate. Silver cations are basically Ag+, and then the Cl-, they come together and they give you the AgCl white precipitate, and that is what you call the precipitation reaction. They come together as a result, silver cation, Ag+, and the Cl- forming the white precipitate. Silver bromide is cream precipitate, confirming Br- is present. Yellow precipitate, iodide is present because of the silver iodide being produced. Last but not least, we also have sulfate. Sulfate comes from sulfuric acid. So the formula of sulfuric acid, one of the 3 common acids from the acid, base, and salt topic. Sulfuric acid has 2 H+, and therefore the charge on the SO4 is actually 2-. Sulfate ions, you also have to add dilute nitric acid, and then you add aqueous barium nitrate. Aqueous there basically means it's a solution. It is soluble. It's not a precipitate. You get a white precipitate as a result of barium cation combining with sulfate to give you barium sulfate there. Now for the test on cations, aluminium 3+ basically is quite interesting because insoluble in excess, white precipitate soluble in excess to give you a colorless solution there. So that is one key difference between Al3+ and zinc 2+, which give you the exact same observations with both sodium hydroxide and ammonia. So you need to use sodium hydroxide. You need to use ammonia to tell the difference because it's insoluble in excess ammonia, but zinc 2+ is soluble in excess ammonia. The other thing which is confusing is this green precipitate. and this green precipitate, but this one is soluble in aqueous, insoluble in aqueous. That is the difference there. So one reagent which you can tell the difference between the green precipitate is add excess more than what you need. Just keep on adding in the test tube sodium hydroxide, and if it is soluble in aqueous, you will get a green solution because it dissolves in aqueous. That is chromium 3 plus present. If it is insoluble in aqueous, that's iron 2 plus. Again, as I mentioned, watch the practical video. The practical video number 1 basically outlined the full observations for the cations as stated in this table here. Now the other thing which is very interesting is the copper 2 plus. So for a lot of the transition metals like iron 2 plus and iron 3 plus, you will see the exact same observation between the sodium hydroxide test and the ammonia test. However, for the copper 2 plus, just like with the chromium 3 plus, they have different observation. Here is soluble in aqueous, here is insoluble in aqueous, but copper 2 plus is insoluble in aqueous sodium hydroxide. However, this was the really striking blue color, the dark blue solution, as a result of adding ammonia to excess ammonia to the solution containing copper 2 plus. You get this striking dark blue solution. Do watch through the practical video number 1 for what this test observation actually involved there. We also have the Flam test for metal cations. So these are the group 1. Group 1 metals are called alkali metals. They are therefore the alkali metal cations. They are all +1 because, group 1 metal only has 1 valence electrons, 1 electrons in the outer shell. So to complete the outer shell electrons, they just lose the outer shell electrons. When you lose 1 electron, you become positively charged. This is Flam color, but what I can tell you is all the solutions are colorless. So you can have a look through the Flam test video. So there is the Flam test videos. If I'm not mistaken, I also have it in the practical video number 2 as part of these combined science related practicals for the test on cations, anions, as well as Flam test. This is a red color Flam, indicate Li plus is present. The yellow color Flam, Na plus is present, and lilac color Flam, K plus is present. So in summary, so these 2 pages of tables are given, and these are basically all the tests for gas, cations, Flam test to identify cations, and then we have tests for cations itself, tests for anions, including the color of the silver chloride, silver bromide, silver iodide precipitation by first adding to the halide ions with acid. So you will add nitric acid first, and then you will add the silver nitrate aqueous, the solution, to give you the white precipitate, cream precipitate. Precipitate meaning solid, precipitate meaning you cannot see through it because it comes out as solid from the 2 solutions that combine together. And there was also a test for gas, so we did a test tube test. There are some other apparatus setup, like for measuring time you need a stopwatch, thermometer to measure temperature. Those were things we did from rate of reaction for the stopwatch kind of experiment. Thermometer were in the energy changes experiment, the energy changes topic, exothermic, endothermic. The mass balance were in year 9 under reacting masses, where we have changes in masses, and you did all sort of comparing reacting masses. Volume of gas is basically collecting gas, and you need to read the volume. And that was in the year 10 rate of reaction topic. Volume of liquid were in the year 9. At the end of that reacting mass topic, we talk about concentration, and then we talk about what kind of apparatus are very accurate at measuring volume of solutions. These are volume of solution, very accurate apparatus called burette as well as volumetric pipette. They were in the year 9 combined science syllabus at the end of the reacting mass topic. These diagrams are not too important except for these 2 diagrams here. So these two are basically very important for gas collection. As we had done, as I've shown you the practical setup, there should be water there, by the way, because if there's no water, then there would not be any gas being collected there. So that is just your water. This is collection of water, and our gas will displace the water and you fill up the space there. This involved water is a wet method, whereas this is the dry method. This is a gas syringe. So when we draw a gas syringe, we don't need to draw such complicated setup. We need a syringe, but what is very important in the syringe is make sure that you draw some lines, because we need to read. We need to be able to read. That's the thing. You must show the lines on the measuring cylinder. So that is using measuring cylinder for the third diagram there. And I showed this in the rate of reaction practical videos for gas collections. I did not show using the gas syringe, but basically this is a plunger of the syringe, and the gas as it is formed will start pushing on the plunger outwards, and you have these lines there that indicate the volume of the gas that you are measuring. So this is what you call a gas syringe. And that pretty much sum up this lecture tutorial and this whole topic actually. So you will need to probably watch the two practical tutorial videos so that to further understand the test for cations, anions, the gases, and the flame test. And after those two tutorial videos, we'll just jump onto a couple of example questions as I had shown you in the notes, and as I will show up and follow up. I will follow up and show you the questions, the example questions in the notes as part of the tutorials in this lecture series on qualitative analysis. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. Thank you for watching. I'll see you in the next tutorial video.